For logarithms, this is actually just going to be day 1. So we're not going to do all the notes today. We're going to break it up into 3 days. So welcome to logs. So why do we have to have these logarithms? So first, we know that 2 squared equals 4, and we know that 2 to the third power equals 8. But what if we were talking about 2 to the x power and we were trying to find out what value of x equals 6? So clearly that's some sort of decimal amount. So what we want to do is actually find out what decimal that is without having to play guess and check. So we can figure out that it's somewhere between 2 and 3 because 2 squared is 4 and 2 to the third power is 8. So somewhere between like 2.1 or 2 to the 2.1 power or 2 to the 2.2 power, whatever. So we can figure out a way to actually find the value without having to do guess and check. So here's the definition of a logarithm. You don't need to write this down. Just listen to what I'm saying. So let b and y be positive numbers where b cannot be, excuse me, b cannot be 1. So if you look at where b and y are in the equation here, b is the base and y is what we're trying to find the base of. Okay. So one thing that you need to know is that logarithms always equal exponents. Okay, logs always equal exponents. So b to the x power, do you see where the x is? How the x is the exponent? And do you see how log equals the exponent? So logarithms actually live on exponent world. So that's important to know. So the expression log base b of y. That's how you read that, log base b of y. So this is the logarithmic form. Do you see where the base is? Do you see where the base is? Logs always equal exponents. So this is the exponent. And you can see the exponent over here. And then of y is what you would get for the answer. Okay? So let's practice. I know this is a lot, but this is all brand new. So first thing you do is you look for the base. So 2 is the base. Remember that logs always equal exponents. So the 5 goes up here. And if I work out 2 to the 5th power, I actually will get 32, which is what that is. So again, you start with the base. 5. Logs always equal exponents. 0 gets up here. What's 5 to the 0th power? 1. We look over here. Yep, we're good. So then we do part C. The base is 10. Logs always equal exponents. So the 1 goes up here. 10 to the 1st power is 10. We look over here. It should be the same number. Yay. Do it again. So 10. Base is 10. Logs always equal exponents. So the negative 1 goes up here. Equals. What do you do with negative exponents? You put it downstairs. So that's 1/10. And this is always also 1/10. And then we go to the next one and write down 1/2. That's the base. Anytime it's a fraction, you put it in parentheses. Logarithms always equal exponents, so the negative 1 goes up here. Remember what a negative 1 power does, it makes a reciprocal. So this would be 1 to the negative 1. This would be 2 to the negative 1, which means they both trade places. So we get 2. Look over here. I'll be darned. We're winners. So we did discover that whenever a logarithm is equal to 0, that's because the exponent was 0. Whenever the base and what you're taking the log of match, you will always get 1. So that'll happen whether you remember these special log values or not. Just understanding where the things go, it'll automatically happen. All right, let's look at what's next. Okay, so now, when these are in your book, they are not going to have this little equals x part, right? So it'll look like this in your book, and it'll say evaluate without a calculator. So when you go to write these on your paper, you always want to write the equals x part. So that really helps you to write the equation. So you do just exactly what we just did. So we're going to write down the 3. Logs always equal exponents, so the x is going to go in the exponent, equals 81. The big number here is going to go on the other side at 81. So this is really asking us 3 to the what power gives 81. So 3 to the 1st power is equal to 3, so that one didn't work. 3 to the 2nd power is equal to 9, so that didn't work. 3 to the 3rd power is equal to 27, that didn't work. 3 to the 4th power is equal to 81. So x is equal to 4. And you just kind of go through this until you figure out which number it is. So now we're going to do this log. We're going to first, when we write it down on our notes, we're going to write it down and then we're going to put equals x. So you're going to look at the log to find the base, which is 5. Logarithms always equal exponents, so the x goes up here, equals 0.04. So I need to figure out how to turn a 5 into a decimal. So first what we're going to do, we know that in order to go from a whole number to a decimal, the exponent has to be negative. So what is 5 to the negative 1 power? So we get 0.2. What is 5 to the negative 2 power? We get 0.04. So what must x be to get 0.4? Oh, 0.04. Sorry, I wrote that down wrong. It should be 0.04. So x is equal to negative 2. All right, so let's do this again. So first we're going to write down log 1/2, log base 1/2 of 8 equals x. So add the equals x part on. That will not be there in the textbook. So we're going to start with the base 1/2. Logarithms always equal the exponent, and then we have equal the big number. So when you go from a fraction to a whole number, that means that the exponent must be negative. So I'm going to do 1/2 to the negative 1 power. So my calculator, I'm going to do parentheses, 1 divided by 2 parentheses, raised to the negative 1 power. I'm going to get 2. Then I'm going to do 1/2 raised to the negative 2 power, and I'm going to get 4. And then I do 1/2 raised to the negative 3 power, and I get 8. So what power of x is going to give us 8? So x is equal to negative 3. Right, the last one. So we start with base 9. So we write down in our notes, log base 9 of 3, we add the equals x part. So we're going to write it in exponential form. The 9 logarithms always equal the exponent, and then equals the big number. So in order to go from a bigger number to a smaller number, it means your exponent is a fraction. So if I look at this, I think of 9. What is the connection between 9 and 3? Well, the square root of 9 is 3. So remember that you can also write the square root of 9 as 9 to the 1/2 power, right? That's equal to the square root of 9, which is equal to 3. So x must be equal to the 1/2 power, right? So, or x is equal to 1/2. So let's look at this next. So we're going to do this again. So first off, we're always going to add these x's. So whenever we have it in the book like this, it's just going to have the part without the x's. It's going to be plain. I put the equals x there in red to kind of draw your attention to it. But it's just going to say log base 15 of 15, and there's going to be nothing after it. So you have to add the equals x part to make the problem a lot easier. So we turn it into exponential form. We start with the base, raise it to x equals the big number. So 15 to the what power equals 15? That would be the first power. So x is equal to 1. Over here, we do this one. So write down on your paper log base 7 of 49, and then you're going to add on the equals x part. So we're going to have base 7 raised to the x power is equal to 49. So 7 to the what power equals 49? That would be the second power. So x is equal to 2. And we do this one. Write down on your paper log base 6 of 216. We're going to add on the equals x part. So 6 to the what power equals 216. So this one's not quite as easy. So we'll start out with 6 to the first, 6 to the second, 6 to the third, so at 6 raised to the third power makes 216. Then we're going to do this one. So write down on your paper log base 9 of 1 equals x. We're going to have base 9, x power equals 1. Well, the only way to go from a number back down to 1 is when the exponent is 0. So you can check your work. 9 to the 0th power is indeed 1. So thank goodness. All right, so we're going to do a few more. So this is what happens when we have fractions, right? So number 5, we're going to write down log base 1/2 of 8, and we're going to add on the equals x part. So we're going to have base 1/2 raised to the x power equals 8. So if you notice, in order to go from a fraction to a whole number means that our x has to be negative. So we're going to plug in -1, we're going to get 2. We're going to plug in -2 and get 4. We're going to plug in -3 and get 8. All right, so I think we did that one earlier. Now let's look at this one. Log base 3 of 1/27 equals, add the equals x part. Base 3 raised to the x power equals 1/27. So again, the only way to go from a whole number to a fraction is if x is equal to a negative number. So think about what 3 to the first power is. 3 to the first power is equal to 3. 3 to the second power is equal to 9. 3 to the third power is equal to 27. But we don't have 27, we have 1/27, which means that it's got to be -3. And again, you can check your answer. 3 to the -3 power, right? That means 1/3 cubed, which equals 1/27. So again, we're winners. All right, so let's look at number 7. Write this on your paper. Log base 16 of 1/4, add the equals x part. The base is 16, x is our exponent equals 1/4. So the only way to go from a whole number to a fraction is if the x is negative. So if you see, how do we go from 16 back down to 4? Well, if you look at this, the relationship between these two is if I take the square root of 16, I'll get 4. So if I take 16 and raise it to the 1/2 power, I'll get just the number 4. But I don't want the number 4, I want the number 1/4. So if I take 16 raised to the number -1/2, that will give me 1/4. So x is equal to -1/2. Right? We knew it had to be negative because it became a fraction, and we knew it had to be a half power because the relationship is the square root of 16 is 4. All right, let's do this one. So write down on your paper log base 1/4 of 16 and then add the equals x part. So 1/4 goes in parentheses, raised to the x power equals 16. So it's just exactly the opposite of this one. So how do I go from a fourth? How do I go from a fraction to a whole number? Well, the exponent has to be negative. So let's do 1/4 in parentheses raised to the -1 power. We get 4. Let's do 1/4 in parentheses raised to the -2 power. We get 16. So if x is -2, that will give us 16. Right? So whenever you have something with a base 10, that's called the common log. So the calculator you have that has a log button on it doesn't have a little base with it most often because it's just assumed that that log is base 10, right? So this is what your calculator usually says without a little base because it's assumed that it's 10. The logarithm with base e is called natural log. So usually the button on a calculator says capital L and capital N or lowercase l and lowercase n, and that means natural log. Its base is e, that same e that we talked about in 7.3. So we could write it log of base e, but we don't. We just write it as natural log. So natural log means base e. And if you look at your calculator, base e and natural log are on the same key, and base 10 and log are also on the same key. So your calculator actually kind of talks to you. All right, so common log. We know that whenever it says plain old log, that implies that there's a base 10. Whenever we see natural log, that implies that it has a base e. All right, so these are how you enter the stuff in your calculator. If you don't have your calculator at home, then use the calculator on the computer to at least practice, or your cell phone. So what is the base of this log? This is base 10, which means all I have to do is hit the log key on my calculator, hit the number 5, press enter. If you have one of the backwards calculators, a one-line calculator, then you would have to hit 5, log, enter. So make sure you get this number. If you don't get this number, please make sure that you come in tomorrow and let me show you how to use your calculator real quick. All right, so natural log, you just hit the LN key, you hit 0.1, you push enter. Again, if you have one of the backwards calculators, you have to do 0.1 LN. The backwards calculators have like that yellow second key on them. They're one of the TIs. They're usually brown or black, not the pretty colored TIs. All right, so and then let's do log base 7. Oh, my light's turned off. All right, so log base 7. So hit the log key, or sorry, log base 10 of 7, and press the number 7, and you get 0.8451. Usually go to 4 decimal places. Right, our book got a little crazy here on all these other decimal places. And then I'm going to do natural log 0.25 equals. And I'm going to get negative 1.3863. So again, 4 decimal places. All right, so what we're going to talk about is where the logs live on a number line. So there isn't really anything that you need to do on this. We just need to understand where their position is. So as logs increase, remember that logs are equal to exponents. All right. So if we look at like the value, is log 1, natural log 110 the same as or different than the log of 110? So this guy has a base e and this guy has a base 10. So we're saying e to the what power is equal to 110 versus 10 to the what power is equal to 110, right? We don't know exactly what that power is because it's not a whole number. E is 2.72. So how many times do I need to take 2.72 times itself to get to 110 versus how many times do I need to take 10 times itself to get 110? So hopefully you can see that this guy would be smaller, or sorry, would be bigger than this guy, right? Because it's going to take fewer times to take 10 times itself to get 110 versus how many times I'm going to have to take 2.72 times itself to get 110. Right? So then if we look at this one, log base 27. So 10 to the what power is going to make 27, right? So that's a pretty small number. This one's at least 2, right? Because 10 to the second power is 100. This guy, 10 to the first power is 10. 10 to the second power is 100. So that one's not even 2. So he's got to go here somewhere. Natural log. E to the how many powers makes 15? So E is 2.72. So how many times am I going to have to make 2.72 times itself to get 15? So that's almost 3. So 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. So this is probably somewhere between 2 and 27. So somewhere probably around here. So if I have log base 10 or log base 10 of 90. So you're asking yourself, how many times do I have to take 10 by itself to get 90? So almost 2 times. So a little bit less than 2. So that's going to be kind of here with all those guys. And then you're asking yourself, how many times do I need to take 2.72 times itself to get 10? So just a couple times. How many times do I need to take E times itself to get 0.4746, right? Or sorry, E is here, and then log. So which one's bigger? This is 10 to some power to get 0.746. This is E to some power to get 0.746, right? So we have to figure out which value is bigger. We can also plug in our calculator. If we had the natural log of 0.746, it's going to be negative, right? We knew it was going to be negative because it went to a decimal. 0.293. If I do log base 10 of 0.746, we're going to get negative 0.127. So it makes sense for the 10 to be closer to 0 because you're going to have to multiply 10 by itself less times than you are going to have to multiply E by itself to get the same value, right? And then log of 6.2, how do I go from 10, base 10, to a 6? So I went down, I got smaller, so that's got to be a little number. It's got to be positive because it's still a whole number there. It's still greater than 1, so it's still got to be positive, but it's pretty close to 0 there. So hopefully that kind of makes sense. I know I ended up putting all the numbers on top of each other. We'll talk about this again tomorrow in class because I really want you to see where these numbers lie on the number line. So that's the end of our notes today. Tomorrow we're going to practice using those logs and doing all kinds of fun stuff on our log day.